All right, today we are going to divide polynomials using long division. Tomorrow we're going to divide polynomials a different way, but today we are using long division. Long division is something that you learned in elementary school. You learned how to long divide just normal numbers. So let's start there and kind of recall what you should already know. If I want to do 985 divided by 5, that can also be written, it can be written in a fraction like this, or it can also be written as 985 divided by 5. Either way, we're going to build a box or a house, whatever your elementary school teacher called it. We're going to take 985 and it's going to go on the inside. And then divided by 5 is going to be on the outside. Yes, today is 2-column notes and we're going to have our math and then our steps. We're not going to write the steps for these first two examples because this is just kind of reminding you of what you already know. We will write the steps for our new examples, or for what's new to you, okay? So what you should remember is that when you divide in long division, you want to know how many times does 5 go into 9. Well, 5 divides into 9 one time. Then you do 1 times 5, and you subtract to figure out what's left over. So 9 minus 5 is 4. Bring down the next number is the 8. How many times does 5 divide into 48? 5 goes into 48 9 times because 9 times 5 is 45. Then you subtract to figure out what's left. 48 minus 45 is 3. Bring down the 5. 5 divides into 35 7 times because 7 times 5 is 35. And we have 0 left over. So 985 divided by 5 is 197 with no remainder. There's nothing left over. So it divides evenly. Example 2, if I have 753 divided by 4, that's the same as saying 753 divided by 4. So it can be written as a fraction or as a division question. Either way, we're going to take the first number, the 753, and put it on the inside. We're going to put the 4 on the outside. So now you start asking yourself, how many times does 4 divide evenly into, or not evenly, but divide into 7? 4 divides into 7 one time, because 1 times 4 is 4. Subtract, you have 3. Bring down the 5. How many times does 4 divide into 35? 8 times, because 8 times 4 is 32. Subtract. 35 minus 32 is 3. Bring down the 3. How many times does 4 divide into 33? 8 times. 8 times 4 is 32. Subtract, you have 1. And there's no other numbers to bring down. So I have a remainder of 1. And there are lots of ways to represent the remainder or the leftovers after division. Today we're going to use those remainders and we're going to write them as a fraction. So we're going to say we have 188 and 1/4 left over. So my answer, when I take 753 and divide it by 4, I have 188 and 1/4. Okay? We're going to use that same concept, that same how many times does this go into that, and then multiply and then subtract. We're going to use that same process, but our situations look kind of weird because now we're looking at polynomials and not just numerical values. So now let's start writing our steps because this is going to get pretty weird pretty fast. First of all, we have x squared plus 7x minus 2 divided by x minus 2. That can also be written as x squared plus 7x minus 2 divided by x minus 2. So you can see it as a fraction or you can see it as the division written out. Either way, inside, we're going to put the x squared plus 7x minus 2. Outside will be our x minus 2. So still, same steps. Okay, now, the first thing you need to look at is you need to look at your very first term. My first term is x and x squared. So you need to ask yourself, step 1, what can I do x times, so let's rewrite that. Sorry. We're going to take x, the first term of the outside, times what will give us the first term on the inside, x squared. So what can I multiply by x to get x squared? X. X times x would give us the x squared. So I'm going to multiply x times 1x, and that will work. Now, when you write that on the top of your division bar, you're going to line it up with the like term. So 1x is going to go above the 7x, not above the x squared, just so you can kind of keep like terms aligned. Okay, now after that, we're going to multiply. So I'm going to take the 1x times the x and times the -2. So 1x times x, 1x squared. 1x times -2, -2x. I'm going to subtract those to find my answer. So multiply, subtract. Just like what we did with numbers. Okay, now, when you subtract, really, when you subtract, it's like distributing a -1. So we're doing x squared minus 1x, oops, sorry, is 0. That's gone. 7x minus -2. Kind of have to think of that as now it becomes a +2 because of the minus sign. So 7 plus 2, or 7 minus -2, is really 9x's. Okay? Now, we are going to bring down the -2. Okay? Now, step 4. Again, we're going to look at the x. I don't really know why I started writing in different colors. I'm sorry. Ignore the colors. I'm just going with whatever color I got. Now I need to say, okay, I have that first term x times what will give me 9x. Well, x times 9 would give me 9x, so that means that a positive 9 will be my next number. Now I'm going to multiply, so again, and after we multiply, we're going to subtract. So 9 times x is 9x. 9 times -2 is -18. You're going to subtract that whole line. 9x minus 9x cancels. -2 minus -18. Again, it's kind of changing it to a plus. So -2 minus -18 is a positive 16. I don't have any other numbers to bring down, so 16 is my remainder. So it's positive, so I'm going to add 16 over. We're going to put it in a fraction, just like we did with the 1 and the 4. We're going to put it over what was on the outside, and the outside is x minus 2. So step 7, we're going to write the remainder as a fraction. All right, so my answer, my final answer, when I do x squared plus 7x minus 2 divided by x minus 2 is a single x, so you don't have to write the 1, plus 9 plus 16 over x minus 2. All right? Next example. 4x to the 4th plus 5 divided by x squared plus 2. Again, I could say it's 4x4 plus 5 divided by x squared plus 1. It doesn't matter how it's written. Inside, we're going to put the 4. Oh, now, here's what's kind of a new step. So step 1, we need to write all terms, even if they're not shown. So what I mean is when this starts at 4x to the 4th power, I need to write x to the 3rd power and x to the 2nd power and x to the 1st power, but they're not there. So I have 4x to the 4th power plus 0x cubes plus 0x squareds plus 0 x's, and now I can write the plus 5. So you have to include all possible terms between where you start and where you end, okay? Then on the outside, we have the x squared plus 1. So again, we're going to look at the first terms. So step 2, you need to ask yourself the question, x squared is the first term on the outside, times what will give us the first term on the inside, 4x4. So x squared times 4x squared would give us that answer. So my first number on the top is going to be 4x squared, so I'm going to put it on top of the x squared. Okay, now I forgot one thing. If we have to write all terms on the inside, we also have to write all terms on the outside. And I forgot to fill in the term for the x. So really I have an x squared plus 0 x's plus 1. Make sure you fix that on your paper, okay? So we took the first term, figured out what I can multiply it by to get this first term. So if I know I'm going to multiply by 4x squared, I put it on top of x squared, and now I multiply. 4x squared times x squared is 4x4. Because 4 times 1 is 4, and x squared is x4. You add the exponents. 4x squared times 0x's is 0x cubes. 4x squared times 1 is 4x squared. Okay? We're going to subtract all of this. So now I have 4x4 minus 4x4 is nothing. That cancels. 0x cubes and 0x cubes is still 0x cubes. Now I have 0x squared minus 4x squared. So I have a negative 4x squared left over. Don't forget that we are subtracting everything. You might want to change your signs inside so you don't forget about that. Okay, now I'm going to bring down the next term. Okay, but before I continue, I need to notice that now on the bottom I have a 4x squared plus 0x. That's 2 terms. But on the outside, I have 3 terms. So I'm going to go ahead and bring down the 5 also, because I need to keep the same number of terms on the outside and on the bottom. All right, so step 3 was to multiply. Step 4, we remembered, don't forget you're subtracting. All right, now step 5, I need to ask myself that question again. The first term is x squared, 1x squared. X squared times what will give me the first term I have now, negative 4x squared. X squared times negative 4 is going to give me negative 4x squared. So I'm going to write a minus 4 is next on top. Step 6, we're going to multiply. Next, we're going to subtract. Negative 4 times 1x squared is negative 4x squared. Negative 4 times 0x is 0x. Negative 4 times 1 is negative 4. We are subtracting all of this, which means all of our signs are going to change. Negative 4x squared minus negative 4x squared is really negative 4x squared plus 4x squared is gone. The 0x's are gone. 5 minus negative 4 is really 9. Okay? I don't have anything else to bring down, so 9 is my remainder. It's positive, and I'm going to put it over. Now, when you write the remainder, you can write the original. You don't have to write this 0 filler that we used, okay? So we're just going to say x squared plus 1. So step 8 was the remainder as a fraction. So my quotient, my answer to the division problem is 4x squared minus 4 plus 9 over x squared plus 1. Okay? Last example. We have 6x4 plus 2x cubed plus 5x plus squared plus 3x divided by 3x squared plus x minus 2. Now this looks like a lot more than the last one, but remember the last one we had to put all those filler things in. So what's nice about this one is it kind of already has all that. We have x4, x3, x2, x1. Okay, so we're going to put on the inside 6x4 plus 2x3 plus 5x squared plus 3x. But I am missing the number without an x. So just like up here we ended with plus 5, you need to end with a number that doesn't have an x always, okay? All right, then on the outside we have 3x squared plus x minus 2. Again, no numbers are skipped, so we are good to go. Step 1, ask yourself the question. My first term here is 3x squared. So I'm going to ask myself, 3x squared times what is going to give me the first term inside, 6x to the 4th power. I'm going to write that 4 a little smaller because it doesn't really look like a power. Okay. 3 times what is 6? 3 times 2 is 6. X squared, and what would give me x4? Well, 2 more would give me x4. So I'm going to multiply 2x squared. So it's going to go above the x squared. Step 2, we're going to multiply that. And then step 3, we're going to subtract. 2x squared times 3x squared. 2 times 3 is 6. X squared, x4. 2 times 1 is a positive 2. X2, x1 is x3. 2x squared times negative 2. 2 times negative 2 is negative 4. Keep the x squared. Now we're going to subtract all of that. 6x4 minus 6x4 is nothing. 2x3 minus 2x3 also cancels. 5x squared minus negative turns to plus. 4x squared is 9x squared. Bring down the 3x. So now I need to ask myself, oh, remember I have 3 terms on the outside, so I need 3 terms here also. So we're going to bring down the 0. If I only had 2 terms on the outside, then I would just bring down one of those numbers and we would go again. But because there's 3 on the outside, you need 3 to go into. So now I need to ask myself, if I have 3x squared times what will give me the first term here? 9x squared. Well, 3 times 3 would be 9. X squared is already there, so I just need to positive 3. 3 times 3x squared is 9x squared. 3 times 1x is a positive 3x. 3 times negative 2 is a negative 6. Remember, you're subtracting. 9x squared minus 9x squared is nothing. 3x minus 3x also cancels. 0 minus negative 6 turns plus. And we have a positive 6 left over. So we're going to add 6 over 3x squared plus x minus 2. So my quotient, the answer when I divide, is 2x squared plus 3 plus 6 over 3x squared plus x minus 2. So after I figured that out, then I multiplied. And then I subtract. And then I wrote the remainder as a fraction. Okay, now here are 5 examples, or really 3 examples and 2 reminders of what you already know about dividing. But I need you to also look at my odd answers, because sometimes you don't have a remainder. And if you don't have a remainder, then there's no need to write that part. Sometimes you have lots of zeros. So as you work today, really look at my odd answers as more examples if you get stuck. The odd answers today are written on page 2 of the document instead of in a new link. Okay? And that's it.